Hey folks, how's it going? So one thing I hear flat earthers say all the time is that gravity is a theory, it's never been proven, it's not real. Now, either they're lying or they haven't done their own research, they tell us to do it all the time, and they don't know about all the experimentation and evidence that there is for gravity. Now one thing I've brought up several times, and flat earthers like to run from, is the Pound-Rebka experiment. I've done a few videos on this months back, like almost a year. And Pound-Rebka experiment, using gamma radiation, was actually able to prove and demonstrate and measure the gravitational effects of on the redshift blue shift of the gamma radiation. Now this is done in a controlled environment, and actually is repeatable and demonstrable, and was actually proven again, refined a bit more with the Pound-Snider experiment that came a couple years later. So I'm going to show you a little bit of something to kind of detail it again, and you're more welcome to research and look into this, or look at other videos that were done a while back in which I explained it in greater detail. Let's have a look. Explain the Pound-Rebka experiment.
The Pound-Rebka experiment, conducted in 1959 by Robert Pound and Glenn Rebka, aimed to test Einstein's prediction of gravitational redshift within the context of general relativity. This prediction states that light emitted from a source in a gravitational field will appear to have a lower frequency, redshifted, when observed by an observer outside of that field. Here's a breakdown of the experiment. Setup. A source of gamma rays was placed at the top of a tower at Harvard University. A detector was placed at the bottom of the tower. The height difference between the source and detector created a significant difference in gravitational potential. Procedure. 1. Gamma rays were emitted from the source towards the detector. 2. Due to the gravitational redshift, the gamma rays were expected to lose energy as they traveled downward. 3. To compensate for this energy loss, the source was moved slightly upwards at a specific velocity using a vibrating speaker. 4. This Doppler shift, caused by the source's motion, increased the frequency of the emitted gamma rays, effectively cancelling out the gravitational redshift. 5. The detector at the bottom of the tower measured the frequency of the incoming gamma rays. Results. The experiment successfully detected the predicted gravitational redshift, confirming Einstein's theory of general relativity. The measured redshift was incredibly small, amounting to only a few parts in 10 to the power of 15, but it was statistically significant. Significance. The Pound-Rebka experiment provided strong experimental evidence for the existence of gravitational redshift, a fundamental prediction of general relativity. It demonstrated that gravity not only affects the motion of massive objects, but also influences the behavior of light and time itself. This experiment has had far-reaching implications in various fields of physics, including cosmology and astrophysics.
Was the Pound-Rebka experiment good evidence of gravity?
The Pound-Rebka experiment provided strong evidence for the existence of gravitational redshift, a fundamental prediction of Einstein's theory of general relativity. It demonstrated that gravity not only affects the motion of massive objects, but also influences the behavior of light and time itself. This experiment has had far-reaching implications in various fields of physics, including cosmology and astrophysics.
Did the Pound-Rebka experiment control for confounding variables?
Yes, the Pound-Rebka experiment did control for confounding variables. Some of the key considerations included temperature control. Temperature fluctuations can significantly impact the frequency of the gamma rays. The experimenters meticulously controlled the temperature of both the source and detector to minimize these effects. Doppler shift compensation. To counteract the Doppler shift caused by the Earth's rotation and other factors, the experimenters used a sophisticated system of vibration to precisely adjust the frequency of the gamma ray source. Background radiation. The experiment was conducted in a shielded environment to reduce interference from background radiation. Instrumental drift. The instruments used in the experiment were carefully calibrated and monitored to account for any potential drift in their readings. By carefully considering and controlling these potential confounding variables, the Pound-Rebka experiment provided strong evidence for the existence of gravitational redshift, supporting Einstein's theory of general relativity.
Did the Pound-Rebka experiment control for electromagnetic interference?
While the Pound-Rebka experiment did not explicitly address electromagnetic interference as a major concern, the nature of the experiment and the technology of the time minimized its potential impact. Here's why. 1. Gamma ray nature. The experiment used gamma rays, which are high-energy electromagnetic radiation. These are less susceptible to interference from common sources of electromagnetic noise, like radio waves or microwaves. 2. Shielding. The experiment was likely conducted in a controlled environment, potentially shielded from external electromagnetic sources. 3. Precise measurement techniques. The experiment relied on the Mossbauer effect, which provides extremely precise measurements of energy shifts. This precision could help to distinguish between true gravitational redshift and potential interference effects. While electromagnetic interference was not a primary concern, the experimenters likely took general precautions to ensure a clean experimental environment, minimizing any potential impact on their results.
Was the Pound-Rebka experiment repeated to account for accuracy?
While the Pound-Rebka experiment itself was not directly repeated, subsequent experiments have been conducted to further refine and verify the results. These experiments have used different techniques and improved technology, but they all build upon the foundational work of Pound and Rebka. For example, the Pound-Snider experiment, conducted a few years later, improved upon the original experiment by increasing the accuracy of the measurements. This provided further evidence supporting Einstein's theory of general relativity and the existence of gravitational redshift. Although the exact experimental setup of Pound-Rebka may not have been replicated, the underlying principles and the general approach have been used in various experiments, strengthening the confidence in the original findings.
So the results from the Pound-Rebka experiment are repeatable and demonstrable.
Yes, the results of the Pound-Rebka experiment are considered repeatable and demonstrable. While the exact experimental setup might not be replicated in every detail, the underlying principles and the general approach have been used in various experiments, strengthening the confidence in the original findings. Subsequent experiments, such as the Pound-Snider experiment, have further refined the measurements and provided additional evidence supporting the theory of general relativity. It's important to note that scientific experiments are always subject to refinement and improvement. However, the core results of the Pound-Rebka experiment, demonstrating the gravitational redshift of light, have been widely accepted and incorporated into our understanding of the universe.
So there you have it. The Pound-Rebka experiment was actually an experiment that was done. You can look into this, find the papers on it, and read it if you like. I have actually posted this up before, and as I said before, in greater detail and explain the experiment a lot more. Now, a lot of flat earthers try to claim that it was electromagnetism or some sort of other radiation, but as you can see from that, they actually controlled for confounding variables, and the instrumentation was accurate enough that they could determine if it was just electromagnetism or if it was what they're looking for, and then they went to post the results. And then obviously the Pound-Snider experiment and other such experiments that refined the techniques, and they got the same results, even actually a bit more accurate, with more accuracy. So yeah, that's about it. So gravity is a real thing. We can demonstrate it, we can measure it, and we can prove that it is a real force that is happening. And it's down to, you could say, general relativity, or you could say down to Newtonian gravity. Depends on how accurate you want to go. Both actually work hand in hand. Einstein never refuted Newtonian gravity. General relativity was just a way of being able to explain it with a much more accuracy and a larger scale, with using the bending of space-time. But the attracting mass still works, because if you think about it, it's mass attracting mass, which is bending the space-time. They actually both work hand in hand. General relativity and Newtonian gravity both actually work, and you can use either one depending on how accurate you need to have it. Thanks for watching, and don't forget to follow me for more videos. Ah yes, the good stuff. Always sweeten my coffee with the tears of Flurfs.